Hello everyone, welcome to the channel Code Like Him. Let's see today's problem, count inversions. Given an array of integers ARR, you have to find the inversion count of an array. The inversion count is the number of pairs of elements ij such that I is less than j and array of I is greater than array of j. So in this question we are given an array of integers and we need to count the number of count inversions. So what is a count inversion? I and j, let's suppose I and j are indexes. So I should be less than j and the array of I should be greater than array of j. Let's see this example 2 4 1 3 5. The sequence of 2 3 2 4 1 3 5 has three inversions. 2 1 here 2 is at index 0 and 1 it is index 3, but 2 is greater than 1. So this 2 1 pair is a count inversion. 4 1 here 4 is at index 1 and 1 is at index 3. This pair is also count inversion. And 4 3, this 4 and this 3 also make a pair, so this is a count inversion also. So we have three count inversions, so we'll be written 3 as an output. In this example, all the elements are in the sorted order, so there is no count inversion, so answer will be 0. So in this question what we can do is we can thought something like merge sort, and while merging the array we can count the number of elements. While merging we have two halves, so we can simply count the number of elements on the left half which is less than the number of elements to the right half. Let's see the code to make it clear. So we will simply take the input array of size as n, and we will call this function solve with low to be 0 and high to be n minus 1 and pass array. In this question what we are doing is we are simply using a merge sort technique, and when low is greater than equal to high, it means there are one or no elements, so we will return 0. Then we will find the mid, which will be low plus high by 2, and we will call solve for recursively for the left half. We will divide the array from the mid, and the left half will be from low to mid, and the right half will be from mid plus 1 to high. These two recursive call will return the number of count inversions in the array from low to mid, so we will store it in the res variable, and this will return from the right half mid plus 1 to high. We will also store it in the res variable. Then we will merge these two half from low to mid and from mid plus 1 to high. We will merge this half, and this function also returns the number of inversions in the whole array. So we will return this res. Now let's see the merge function. So while merging the array in the merge sort, we can count the number of inversions. So how we can do this? So we can simply while sorting the array, we can simply use a temp vector to store the sorted array. So let's see, the I will be initialized to low, and the right half, the right array will be the first index will be initialized with mid plus 1. So while I is less than mid, it means we will iterating the left array, and j will be iterating for the right array. Where I is less than equal to array of j, it means the left array element is less than the right array element, so there is no inversion. We will simply push this array element into the temp variable and simply move ahead. Else, if array of I is greater than array of j, it means we have an inversion here, and the number of inversions will be mid minus I plus 1, because all the elements in the left array from I to mid will contribute to the inversion. Because let's see, if let's say we have in the left array we have 2 3, and in the right array we have 0 1. So the first element 2 is greater than 0 1. So all the elements which are present in the right array from this 2 till the end will be greater. So 2 and 3 will contribute to the count inversion. So we will simply have the count in like mid minus I plus 1, and then we will simply push array of j in the temp and increment this j variable. If one of the array is exhausted, we will simply insert these elements in a temp variable. Well, I is less than equal to mid, we will simply insert it into temp variable and I plus plus. Same for the right array, and then we need to sort the array as well. So from the temp variable we will be replacing all the elements in the array, and simply return resultant variable. So the time complexity of the solution will be same as a merge sort n log n. So and the space complexity for this will be big of n because we are using temporary array. So guys, if you find this video helpful, please like this video and comment. Thanks.